So for this next lab report, you're going to hand in both Lab 3 and Lab 4 as one report. And so Lab 3, the standardization of sodium hydroxide, and Lab 4, the impurity of KHP, both of those will be handed in together in the next lab report. So what you're going to do is for page 1, you're going to hand in Lab 3 report form. Page 2, you're going to have Lab 3 calculations, and notice I only want one representative calculation. So each time a calculation changes to something different, you'll give me that calculation, but I only need one representative calculation. I don't need all of them. And then for page 3, you'll do Lab 4 report form, and then for page 4, your last page, that's going to be your Lab 4 calculations, only one representative calculation for those. And then for the very last page, which I don't have noted here, so last page, whatever that's going to end up being for you, but so it should be page 5 potentially. But for the last page, what I would like is just your data for both Lab 3 and Lab 4. So you can just either copy that over or just take an image of Lab 3's data and Lab 4's data and put them together, and that will work. So let's talk for a few moments about the actual calculation. Here are a few Lab 3 notes. The first thing that I want to note is that you've got a formula here, KHP, which is potassium hydrogen phthalate, not phosphorus. So KHP's molar mass is 204.23 grams per mole. And the balanced chemical equation for the reaction between potassium hydrogen phthalate and sodium hydroxide is shown right here. And so for the first lab, the analyte is sodium hydroxide because that's what we're interested in finding its concentration of. So for this, our key goal in this is to find the concentration of sodium hydroxide. And when I refer to concentration, that means that I want the number of moles of sodium hydroxide in the total volume of sodium hydroxide that is dispensed. And that is in molarity or molar. So that's the big M with a line underneath of it. So in this week's lab, what you did is you actually used KHP. So you had some mass of KHP, roughly 1 gram, so approximately 1 gram. You're going to put all of the digits there, but 1 point, and it'll have 4 digits to the right. So I'm going to make one up, 0001. And this is of KHP, and this was our known value. And you titrated the KHP, so there's KHP in here. You titrated it until all that KHP was dissolved and it turned to a faint pink. And that was your end point. And so we're going to use that information here. And so for every 1 mole of sodium hydroxide that was consumed, 1 mole of KHP was consumed. So what we've got to do with that is to literally figure out how many moles of KHP did we actually begin with. And so to start with, that's what we're going to do. So we're going to convert first from mass of KHP to moles of KHP, noting that we have the molar mass up here. So we're going to use that, 204.23 grams of KHP per mole of KHP. That was given in the actual procedure of the lab. And now that we're in moles of KHP, we have this balanced equation. So we know up here from that balanced equation that for every 1 mole of KHP that was consumed, that 1 mole of sodium hydroxide was consumed because we dispensed the sodium hydroxide into the solution of KHP. If we stop here, that will give us the moles of sodium hydroxide that we actually delivered to the flask here, because we know that for that balanced chemical equation, that for every 1 mole of KHP that was consumed, we had 1 mole of sodium hydroxide that was consumed. So we've already gotten half the way. We've gotten our moles of sodium hydroxide. So the last thing that we have to do is just divide by the volume of sodium hydroxide that it required to titrate to pink. So for me, that actually took about 42.15 mils of sodium hydroxide. Now, notice here, this is in mils, and up here, we've got it in liters. So I've got to convert that mils, so 42.15 mils of sodium hydroxide, I'm going to convert to liters. And we know that for every 1,000 mils, there is 1 liter. So I end up with 0.04215 liters. This is what I will now put under here in order to get to my final answer, which will be in units of molarity, or moles per liter of sodium hydroxide. So whatever the moles of sodium hydroxide is that you calculate from that value, divided by the volumes that it required to get to that endpoint of sodium hydroxide, will give us the molarity of sodium hydroxide. So you'll have that new value once you do the calculation here. And this gives us the concentration of sodium hydroxide for trial 1. Now on your lab report form, you'll go through and you'll put in your mass. So for me, my mass of pure was 1.0001 grams. You'll have your moles of pure KHP that you'll then put in here. And then it asks you for the volume of sodium hydroxide that you used. And then you'll put in your molarity of sodium hydroxide that you calculated. And notice here, that's going to be for trial 1. You're going to find the average molarity, and in order to find deviation down here, all you're going to do to find that deviation is you're going to take the average concentration of molarity minus trial 1, and that's going to be deviation 1. And you're going to do, for the next one, you'll do average molarity minus trial 2, and you're going to put it here. Now, when you get ready to do average deviation, don't forget that average deviation is defined by the absolute value. So once you get these, then you'll take the absolute value, you'll add all of those together if you did 4 trials, and you'll divide by 4 to get your average deviation. And that would be for your lab 3. Now, in terms of lab 4, we have the same reaction. So we'll use KHP, potassium hydrogen phthalate, hence the 204.23 grams per mole, being consumed by 1 mole of sodium hydroxide yields sodium Kp plus water. So the same balanced reaction, but this time our analyte that we're looking for is KHP. So you were given a white powdery substance that had some KHP in it and other stuff. And your goal for this particular lab is to find the percent of KHP in the sample that you were given. And to do that, you will literally need to find what is the mass of KHP in that sample, divided by your sample mass, that's what you began with, times 100. So for me, when we start this, we've got to know a couple of things. We've got to know the concentration of sodium hydroxide from lab 3. So from lab 3, my concentration for sodium hydroxide was 0.1283 molar. And notice my sig figs there. You should have 4 sig figs on that. And that information is going to help us to figure out the percent KHP in the sample. Now remember, when we did this, we still had our titration set up with sodium hydroxide being delivered or dispensed from the burette. And then we had here our sample that had some KHP and other stuff. So we still titrated, and we titrated to the end point, and that's going to be important because that titration means that for every 1 mole of KHP that's consumed, 1 mole of sodium hydroxide was consumed. So this time we know something about sodium hydroxide and we're looking for KHP. So when we begin this, we're going to start with 0.1283 moles per liter, which means the same as molar or molarity, or the big M with a line under it. And for this lab, I ended up, it required for my first trial, in my first trial I had 0.7683 grams of sample. And so there I've got that piece, and now I've got to find my mass of KHP. And to get to the actual end point, it required 32.56 mils. And you all can do that conversion. And so I did that conversion, and it was 0.03256 liters. That's what it required to get to this end point over here, the point at which the sodium hydroxide number of moles and the KHP number of moles were equal. So I'm going to take this volume right here to find out the number of moles of sodium hydroxide that were required to get to that pink end point. And I'm going to multiply the molarity by 0.03256 liters, and that's going to get me to moles of sodium hydroxide. So now that we have the moles of sodium hydroxide that were consumed, I'm going to bring them down here. So moles of sodium hydroxide. I can use the balanced chemical equation above, and note that for every 1 mole of sodium hydroxide that was consumed, that 1 mole of KHP was consumed, as based on this above reaction up here. And then notice here, we're still looking for mole or mass of KHP. Right now, if I were to stop, we would be in moles of KHP. So I've got one more conversion to do. And that conversion is for every 1 mole of KHP, we have 204.23 grams of KHP. And that's going to give me mass of KHP in my sample. So finally, I have the number that will go up here into my mass of KHP per mass of sample. I multiply it by 100, and I can get my percent KHP in the sample. You'll do that same calculation, and then you'll notice also for the lab 4 purity of KHP, you've got to also look at the trials here. You've got volume of sodium hydroxide, and moles, and so forth. And notice here, you're going to have an unknown number that you need to put in. The trial here, one deviation is the same. This time you're going to take the average percent KHP, and you're going to subtract trial 1% KHP, and you're going to plug that in here and so forth. And then you'll answer the question at the end, and you are finished with your Lab 3 and Lab 4, and you can hand them in as one. Best case scenario is that you're able to upload one document as a PDF, and that's what I'll be looking for.